Hello students, we are solving the IB Math AHL past papers and currently we are solving the IB Math AHL May 2022 paper 1 times on 2 past paper. Today we will be solving the question number 12, that is the last question of this paper, and you will be getting the links to all the previously solved questions of this paper and of the other papers in form of playlist in my channel NS Online Math Tutoring Classes. So without any further delay, let us start answering question number 12. The maximum mark is 18. In the following Argand diagram, the points Z1, O and Z2 are the vertices of the triangle Z1OZ2 described anti-clockwise. And you can see OZ1Z2. So we have to read it from starting from Z1, Z1, O, Z2, and in the anti-clockwise direction we are reading. And the point Z1 represents the complex number Z1 equal to R1 times e to the power of I alpha, where R1 is greater than 0. See, Z1 is the complex number and this angle is alpha. This angle is alpha, so this one is R1. This length OZ1 is R1 and R1 is of course greater than 0. The point Z2 represents the complex number Z2 equal to R2 e to the power of I theta. So this one is theta and this OZ2 is R2 length and R2 is greater than 0. Angles alpha and theta are measured anti-clockwise from the positive direction of the real axis such that alpha is greater than or equal to 0, theta is less than 2 pi, and alpha minus theta is greater than 0 and is less than pi. The subpart A says show that Z1 times Z2 star, that is the complex conjugate of Z2, is equal to R1 times R2 times e to the power of I alpha minus theta, where Z2 star is the complex conjugate of Z2. Okay, so let us start with our answer. We are having Z2 equal to R2 e to the power of I theta. If we write this in modulus argument form, we get R2 cos theta plus I sin theta. Okay, and we need the complex conjugate of Z2. So it will be Z2 star and this will be equal to R2 cos theta minus I sin theta. And next we want to get it back to the Euler's form. We want to represent this Z2 star or the complex conjugate of Z2 in Euler's form. How can we represent this in Euler's form? Because in Euler's form, the in-between sign should be plus, but over here it is minus. So we have to convert it to plus sign. So we will be using the knowledge of trigonometry, and we know cos of negative theta equal to cos theta and sine of negative theta equal to negative sine theta. Therefore, we can write this as cos of negative theta, which will be equal to cos theta, and plus I sine of negative theta, which will be equal to negative sine theta. Okay, now you see we are having a plus sign in the middle joining these two. So this will be equal to R2 times e to the power of I and minus theta. Okay, so now we have expressed this Z2 star, that is the complex conjugate of Z2, in Euler form. Next, what are we required to do? We have to multiply Z1 with Z2 star. So Z1 times Z2 star will be equal to R1 e to the power of I alpha, which is Z1, times R2 times e to the power of I negative theta. So this is equal to Z1, Z2 star will be equal to R1, R2 times e to the power of I alpha minus theta. This is e to the power of I alpha and this is e to the power of I negative theta. So when we multiply these two, the powers will get added. So it is R1 times R2 times e to the power of I alpha minus theta. So we have shown this. Okay. Fine. The part B. Given that real part of Z1 times Z2 star equal to 0, show that Z1 O Z2 is a right angle triangle. And if you don't remember the figure, this was the real axis, this was the imaginary axis, and you may take this as Z1. This one was Z1 equal to R1 e to the power of I alpha. This was equal to alpha. And this is O. And maybe I can take this as Z2. This angle was equal to theta because Z2 equal to R2 times e to the power of I theta. And this is the Z1 OZ2 triangle. Okay. And they are saying that we have to prove that Z1 OZ2 triangle is a right angle triangle. Okay. And from the alpha and theta, I'm seeing one of the angles of this Z1 OZ2 triangle is this one. This one is alpha minus theta. Okay. This is an angle from the triangle, of the triangle. Okay. I'm not sure whether this one is a right angle, but obviously if this Z1 or Z2 is a right angle triangle, one of the three angles of this triangle has to be a right angle. It may be alpha minus theta angle is a right angle triangle, is a right angle. We had to prove which one is a right angle. Okay, but first of all, Z1, Z2 star equal to R1 times R2 times e to the power of I alpha minus theta. We had shown this expression to be true in our subpart A. Okay. And then let us, this is subpart B. So we can write this as, I'm just expressing this in modulus argument form. This is R1 times R2 times cos alpha minus theta plus I sine alpha minus theta. Okay, fine. So real part of Z1, Z2 star is equal to R1, R2 cos alpha minus theta. And this is equal to 0, given. This is equal to 0. And also we know R1 is greater than 0, R2 is greater than 0. So because R1 times R2 times cos alpha minus theta has to be equal to 0, therefore cos alpha minus theta is equal to 0 because R1 is greater than 0, R2 is greater than 0. Okay. Therefore, alpha minus theta equal to cos inverse 0 or alpha minus theta equal to pi over 2. Therefore, triangle Z1OZ2 is a right triangle. Okay. So this is the answer for the subpart B. Coming to subpart C, before that they are saying in parts C, D and E, consider the case where Z1 or Z2 is an equilateral triangle. That means alpha minus theta, this is an angle from this triangle, should be equal to pi over 3. Every angle of this triangle should be equal to pi over 3. And another thing that we are having as given, we have to know that this one is R1, OZ1 equal to R1 and OZ2, this part is equal to R2. Okay, and because C1 OZ2 is an equilateral triangle, therefore R1 should be equal to R2. The two lengths should be the same. Okay, so let me start answering the CI part over here. Z1 is equal to, I'm just writing this, R1 times e to the power of I alpha. Okay, and we know that alpha minus theta is equal to pi over 3 because this is an equilateral triangle. So what is alpha? I am expressing alpha in terms of theta because I have to express Z1 in terms of Z2. Okay, so in place of alpha, I will be writing theta plus pi over 3. Clear? So, and in place of R1, I'll be writing R2. So, R2 and e to the power of I theta plus pi over 3. Okay. So, this is R2. I'm just separating this, e to the power of I theta times e to the power of I pi over 3. And what is this part? Z2 equal to R2 e to the power of I theta. Therefore, Z1 is equal to Z2 e to the power of I theta. Not theta, sorry. I pi over 3. R2 e to the power of I theta is Z2. So, Z1 equal to Z2 times e to the power of I pi over 3. Okay. So, we have completed answering CI. Coming to CII. Hence, show Z1 square plus Z2 square equal to Z1, Z2. Hence, show means we will be taking the help of the previous subpart. And okay, so Z1 square plus Z2 square should be equal to, and in place of Z1, I am writing this because we have to take the help of the previous subpart. So it is Z2 and e to the power of I pi over 3 whole square plus Z2 square. Okay. So this is, I can write Z1 square plus Z2 square is equal to, I'm squaring this, Z2 square and e to the power of, if I square this, I get e to the power of I 2 pi over 3 plus Z2 square. And I am taking Z2 square common. And this one is e to the power of I 2 pi over 3 plus 1. Okay. And fine, if I just write this in modulus argument form, what do I get? The modulus is, of course, 1 over here. So this is Z2 square is cos 2 pi over 3 plus I sine 2 pi over 3 plus 1. Okay. And this is equal to z2 square, and cos 2 pi over 3 is negative half because this is an angle from the second quadrant, so this is negative half, plus I sine 2 pi over 3 is root 3 over 2 plus 1, and 1 minus half is half. So this is z2 square half plus I root 3 over 2. And if we want to express this part in Euler's form, what do we get? We have to get the modulus and the argument. For argument, I can convert it to tan theta and get the argument, but over here I can just simply see this is cos pi over 3 is half and sine pi over 3 is root 3 over 2. So I can keep this as pi over 3. Okay. And what is the modulus? For the modulus, I can take the square root of half square plus root 3 over 2 whole square. So this is equal to 1 over 4 plus 3 over 4, which is equal to 4 over 4 or 1. And square root of 1 is equal to 1. So therefore, I can write this as z2 square and e to the power of I pi over 3. Okay. And you see over here we had found z1 equal to z2 times e to the power of I pi over 3. Okay. And we have to use the previous part because it is hence. So, and we need it actually. Therefore, z1 square plus z2 square is equal to z2 square times e to the power of I pi over 3. And I can write this as z2. I'm taking one z2 from this part and I'm writing this e to the power of I pi over 3. And again, I am writing z2. I could have written z2 times z2 e to the power of I pi over 3, but I have written just this part first of all and then z2 because I have to write in place of this, I will be writing z1 and then z2. So this is what we are asked to prove. z1 square plus z2 square is equal to z1 z2. So z1 square plus z2 square equal to z1 z2 shown. Okay. Let z1 and z2 be the distinct roots of the equation z square plus az plus b equal to 0, where z is a complex number and a and b are real numbers. And z1 was equal to r1 times e to the power of I alpha, z2 is r2 e to the power of I theta. These we have already seen these. And part D's question is use the result from part CII. The part CII asked us to prove this, which we had proved. In fact, z1 square plus z2 square equal to z1 times z2, and z1 o z2 was an equilateral triangle. And we have to show this using this subpart CII. We have to show a square minus 3b equal to 0. A is the coefficient of z and b is the constant term. Okay, fine. And they are saying z1 and z2 be the distinct roots of this equation. This is a quadratic equation. Okay, fine. So let us first of all write, since it is a quadratic equation, I am writing the sum of the roots, that is z1 plus z2 equal to minus b over a. B is the coefficient of z, which is a in this case. So this is minus a over the coefficient of z square, which is 1. So z1 plus z2 equal to negative a, and the product of the roots z1, z2 should be equal to the constant term, that is b over the coefficient of z square, which is 1. So z1, z2 should be equal to b. Okay. And we are seeing we are having a square, and they have asked us to use, because we have to in fact use this, which is containing z1 square plus z2 square. So let us square this equation. Okay. Therefore, z1 plus z2 whole square should be equal to z1 square plus z2 square plus 2z1 z2. Okay. And in and this will be equal to negative a whole square, which is equal to a square. Okay. And z1 square plus z2 square equal to z1 z2. So this is equal to z1 z2 plus 2 times z1 z2 equal to a square. So this is 3z1 z2, and z1 z2 is nothing but b. So this is equal to 3b equal to a square, or a square minus 3b equal to 0. We have shown this. Okay. Fine. Consider the equation z square plus az plus 12 equal to 0. This was z square plus az plus b. So b equal to 12. C is a complex number, A is a real number, so but E's question is given that alpha minus theta is greater than 0 and is less than pi. Previously also we had seen right at the beginning of this question, they had given alpha minus theta was greater than 0 but was less than pi. And since if you remember, let me just draw once more the Z1 or Z2 triangle. It was an equilateral triangle. This was the real axis, this was the imaginary axis, and maybe this was the way the z1 or z2 triangle was drawn. This is O, and this is just a schematic diagram. It is not an authentic one, because we do not know the angles. We know alpha minus theta, this will be equal to, this part is alpha minus theta, this should be equal to pi over 3, because it is an equilateral triangle. This much we know, and we do not know anything else. Okay, deduce that there is only one single equilateral triangle z1 or z2 can be formed from the point O and the roots of this equation. This equation z square plus az plus 12 equal to 0. Okay, fine. So let us start answering part E, and first of all let us get the value of E using this equation. A square minus 3b is equal to 0, and b is equal to 12, so a square minus 3 times 12 is equal to 0, or a square is equal to 36. This gives us the a value as plus minus 6. Okay, fine. And let us get the two roots of this equation first of all. So see, I'm using the quadratic formula. I do not have any other option with me, in fact. So it is minus a, because it will be minus b. B is the coefficient of c, plus minus square root of b square, which will be a square, minus 4 times a is the coefficient of z square, which is 1, and c is the constant term, which is 12. over 2a. A is the coefficient of z square, so it is 1. So this will be equal to minus a plus minus a square minus 48 over 2. Okay, fine. And now let us take a as plus 6. When a is equal to 6, positive 6, c will be equal to negative 6 plus minus 36 minus 48 over 2. 36 minus 48 is negative 12. So this can be written as negative 3 plus minus negative 12. Square root of negative 12, I can take square root of negative 1 as I, and square root of 12 is 2 root 3. And 2 root 3 divided by 2 will be root 3. So this is root 3i. Okay, fine. So I can take z1 as negative 3 plus root 3i and z2 as negative 3 minus root 3i. I do not know which one is what. Okay. Okay. And let us see. We know that alpha minus theta has to be equal to pi over 3 because it is an equilateral triangle. So z1, the argument of z1 was equal to alpha, you see, and the argument of z2 was equal to theta. Fine. And if we just consider the quadrants, this will be from the second quadrant because this real part is negative and the imaginary part is positive. So it will be in the second quadrant. And this one will be in the third quadrant. Okay. So let us find the argument because I'm not interested in having the modulus. I have to show that only one equilateral triangle should be there. And we know that alpha minus theta equal to pi over 3. So let us first of all, if I need to go to the modulus, I'll be going to the modulus. But first of all, let us try and check the arguments. The difference of these two, alpha minus theta should be equal to pi over 3. Okay. Let us see whether we get more than one case where alpha minus theta equal to pi over 3. In that case, we have to think of something else to just reject one of them. Or else, if we get a single case where alpha minus theta equal to pi over 3, we can straightforward say that that is why there is only a single equilateral triangle that can be formed. Okay, fine. So this is an angle from the, this is a point from the second quadrant. What will be the modulus? Rather, what will be the argument? The argument of C1 is alpha. It is the second quadrant angle. So it will be, if I take the tan alpha, it is root 3 over negative 3. I'm writing theta, not alpha, or rather I write gamma because I am having theta. So I just want to write some other letter. Tan gamma, because if tan gamma is equal to root 3 over negative 3, I'm not taking negative 3 right now. I am taking tan gamma equal to root 3 over positive 3. So it is 1 over root 3. Okay. I just want the acute angle. So gamma will be equal to tan 30 degrees, or tan pi over 6 is equal to 1 over root 3. So I need the, I was searching for the acute angle, and I have got the acute angle gamma as pi over 6. Now, since it is the second quadrant angle, it will be pi minus pi over 6, which is 5 pi over 6. And this one is located in the third quadrant. So, what will be the theta value? The theta value will be from the third quadrant. Again, the acute angle is pi over 6. And since it is from the third quadrant, the angle will be, theta will be pi plus pi over 6. That is 7 pi over 6. Okay. So, if I take alpha minus theta, then I have 5 pi over 6 minus 7 pi over 6, which is equal to negative 2 pi over 6 or negative pi over 6, pi over 3. It is not pi over 3, but it is negative pi over 3. So I cannot take this. But what if I write C1 as negative 3 minus root 3i, and because I know that two roots will be negative 3 plus minus root 3i. It is I who has decided previously. I had decided this to be named as Z1 and this to be named as Z2. But what if I name this negative 3 negative root 3i as Z1 and I name this Z2 as negative 3 plus root 3i? Then what happens? Then I get alpha as 7 pi over 6 and theta as 5 pi over 6. Okay, because now in this case this will be from the third quadrant and this will be from the second quadrant, and now I am having alpha minus theta equal to 2 pi over 6 or pi over 3, which we know we have to get. Alpha minus theta was equal to pi over 3 because Z1 O Z2 is an equilateral triangle. Okay, this was when E is equal to 6. What if E is equal to negative 6? Then it is minus E. So it will be, Z will be equal to 6 plus minus root 12i. Every other portion will remain the same over 2. So this will be, let me write Z1 is equal to 3 plus root 3i and Z2 is equal to 3 minus root 3i. Okay. So this is from the first quadrant and this is from the second, not second quadrant, rather it is from the fourth quadrant. Okay. And we are having the same thing. It is gamma is pi over 6, which is the acute angle. So I am having Z1 was related to alpha. So I'm having, this is from the first quadrant. So this will be pi over 6. And this will be from the fourth quadrant. So I will be having the equation as 2 pi minus pi over 6. 2 pi minus pi over 6, 2 pi can be written as 12 pi over 6 minus pi over 6. So theta is equal to 11 pi over 6. Okay. So therefore, alpha minus theta is not equal to pi over 3. Yeah. And, but if we just reverse, if we take Z1 equal to 3 minus root 3i and Z2 as 3 plus root 3i, what happens? Then alpha will be equal to 11 pi over 6 and theta will be equal to pi over 6. So even then, alpha minus theta will be equal to 10 pi over 6, which is equal to 5 pi over 3, which is in fact not equal to pi over 3. So in this case, it will be less than 0. So you have to show the 4 cases. You are having only a single case where you are having alpha minus theta as pi over 3, where z1 is equal to negative 3 minus root 3i and z2 equal to negative 3 plus root 3i. So this is the single equilateral triangle there that we can have. Therefore, we can have a single equilateral triangle C1 OC2. Okay, which are the roots of the equation. Okay, so this completes our question number 12. And thank you for staying with me till the end. In case you have liked my explanation, please do give this video a like and please do share this video with your friends so that even they can get benefited by watching my video. And please do not forget to subscribe to my YouTube channel. It will be motivating me to make more math videos for you. I'm Nilanjana Sanyal. I'm an online IB Math ASL and EHL level tutor. I tutor students from both within India and outside India, and I offer both one-on-one and small group online tutoring sessions to my students. And we meet again very soon. In our next session, we will be starting with a new paper, that is May 2022, paper 2 time zone 2, and we'll be solving the question number 1, the very first question of that paper. So till then, bye.